So in today's lesson, we're going to look at how we would actually design a statistical experiment. So let's look at our objectives. The first is, how do we describe the experiments we want to conduct, right? What's the key information that we need to determine and document in our experiment? The second is we want to recognize how randomization applies to experiments and observational studies. We've already learned that when we're taking random samples, right, out of a population to study them, if they're truly random, that gives us the best representation, right, of the entire population. So the same thing holds when we're designing our experiment. And then the third, we're going to look at some examples of experimental design and analyze them. Are they good? Are they bad? What would we change or fix to improve the quality of the experiment? All right, let's look at some definitions here. So how do we describe an experiment? The first term we're going to use is what we call a controlled experiment, where two groups are studied under identical conditions with the exception of one variable. So this is sometimes hard to do, right? But generally what you would do is the group under ordinary conditions that is subject to no treatment, okay? They're not going to receive anything special. We call that the control group, okay? The group that is subjected to the treatment is called, well, it makes sense, the treatment group, okay? So let's take an example. Let's say we are testing out fertilizer, right, on our vegetable garden. And we want to say, does fertilizer really make a difference? So the control group, right, would be the set of plants that we would not apply any fertilizer to. The treatment group would be the group of plants that received fertilizer. And then we would let them grow. And the goal here, right, is to only have one variable, whether they got fertilizer or not, that we change. We try to keep everything else the same, like the amount of water that they get, the amount of sunshine that they get, the room that they have to grow. Now, randomization is a process for randomly assigning subjects to different treatment groups. So in a randomized comparative study, subjects are randomly assigned to the control group or treatment group. So let's take the example of our vegetable garden, right? If we have our plants spread out, right, over the yard, you'd want to randomly pick which groups got the fertilizer and which ones did not, rather than perhaps choose all the plants on one side that get fertilizer and all the plants on the other side of the yard don't get the fertilizer. Now, in some cases, subjects in the control group are given a placebo. Now, the plants don't know what we're giving them, so we don't need to give them a placebo or fake fertilizer. But often in experiments with humans, where we don't want them to know which group they're actually in, right, they would receive a placebo. It might be a placebo pill or even a placebo shot, right? The real drug would be in one syringe. The placebo could just simply be a saline solution, right? Water that is safe to inject, but it's not going to do anything in the participant's body. So some important terms we're going to use here when we're describing experiments. Now let's look at some examples, and we want to evaluate them to see if the study is a randomized comparative experiment. Now, what are we looking for? I've developed kind of a checklist here. And to be a truly randomized comparative experiment, we need to have a control group, a treatment group. Are the subjects randomly assigned to different groups? And are the groups studied under identical conditions except for the one variable? Okay, so those are the four criteria that we have in order to have a truly randomized comparative study. So let's look at an example here. The question we're answering is, does vitamin C lower cholesterol? So vitamin C, you guys know what that is, right? It occurs naturally, especially in fruits and vegetables. And the question is, if you take more vitamin C, will it lower your cholesterol, right? Cholesterol is really how much fat and things like that your body's trying to process in its blood, and basically can cause problems over time, right, with your blood vessels, your arteries getting clogged and plugged up, makes it harder for your heart to pump blood through them. So for the most part, we have good and bad cholesterol, but clearly here, does vitamin C lower bad cholesterol. So here's what the experiment is described as. Patients were given the choice of whether to take 500 milligrams of vitamin C each day. And then 50 patients who took vitamin C, and we had 50 patients who did not take vitamin C. Okay, so those are our two groups, one that took vitamin C and one that did not. And then after 1 year, the patients who took vitamin C have 15% lower cholesterol than patients in the other group. Okay, so now let's go through our checklist. Is there a control group? Well, yes, these are the patients who did not take vitamin C. So we have a control group. Is there a treatment group? Yes, the patients who took vitamin C. Okay, so we have a control and treatment group. Now, are subjects randomly assigned to different groups? Well, here the answer is no, because we gave the patients a choice. It says patients were given the choice of whether to take the vitamin C or not. So we did not randomly have patients take vitamin C. And our group studied under identical conditions except for one variable. Well, not really, right? Since the patients voluntarily took vitamin C, those patients, because they're open to taking vitamin C, may also be more open to healthier foods and healthier lifestyle, right? And healthy eating and exercise will definitely help reduce your cholesterol levels. So this is not a true randomized comparative experiment. Yes, we had control groups, but they were not randomly assigned to different groups, and we really didn't have a way to control the other variables in the experiment. All right, so let's look at another example here. Is the newly designed self-checkout faster? Okay, so a store redesigned their self-checkout, and most stores have these. I hate them personally, but sometimes we don't have a choice. So let's look at how they set up the study to answer that question. So a grocer gathered 142 customers and randomly divided them into two groups. One group used the new checkout, and one group used the old checkout. And they bought the same groceries, right? So they had the same items, the same number of items that they were checking out through the new process. And what they found is that users of the new self-checkout were able to complete their purchases 16% faster. So it looks like the new checkout process is faster. Now, let's evaluate our comparative experiment. Was there a control group? Yes, one group that used the old checkout. Is there a treatment group? Yes, the group that used the new checkout. Are subjects randomly assigned to different groups? Yeah, out of the 142, they randomly divided them into two groups. And then our group studied under identical conditions, except for the one variable. Yeah, the key to control here was they all bought the same groceries, right? So same number of items that they need to scan as they check out. So this would be a good randomized comparative experiment. It meets all of the criteria in our checklist. All right. We're going to talk about now randomization in experiments and observational studies. So in an experiment, our goal is to have individuals randomly assigned to the treatment and control group. We talked about that already. Now, in an observational study, right, this is where we can't apply a treatment to a population, but we can collect information about, how much maybe they exercise, right? And then see how that correlates to other health factors. So when possible, right, we would randomly select samples from the groups or for the groups that are being studied. So again, random sampling or random assignment is really important for the quality of our statistical experiment. Now, let's talk a little more about an experiment. A valid experiment study, by eliminating other variables that can be controlled, okay, can make what we call a valid cause and effect conclusion. Okay, this is a really important concept. If we can control all the other variables except the one that we're evaluating, then we can make a valid cause and effect conclusion. And we call this causality. We can say with high certainty, right? If you exercise, you will be healthier, you will live longer, okay? If you take vitamin C, your cholesterol will go down. Okay, but in order to make that statement, it has to be a controlled experiment where we're only changing one variable. In observational studies, variables other than what are being measured may affect the results, right? Things that we don't have control over. So an observational study can identify the correlation between variables, but not causality. Now, we're using these words correlation and causality. Let's define them a little bit. Causality shows that one variable directly affects a change in another, okay? And if possible, right, we want to do a statistical experiment that will let us establish this causality. Very important from the medical field, right? Think of the vaccines that we've been testing. They want to show direct causality between taking the vaccine and not getting the COVID virus. Now, correlation suggests that yes, there is an association between the two variables, but we can't say with high certainty that the change in one variable is directly responsible for the change in the other. Okay, so experimental studies will allow us to show causality, but observational studies can only allow us to show that there is a correlation. Yes, there's some association, some relationship between the two variables. So this is a key concept here, the difference between an experiment and observational study. In the perfect world, you'd rather conduct an experiment to really show that causality, but often that's not practical, so we have to do observational studies. All right, let's look at an example here. Designing an experiment or observational study. So determine if the topic is best investigated with an experiment or observational study. Then describe how you would design the experiment or study. So here's an example. Does vigorous exercise in older people result in longer life? Well, so the first question is this something we could design an experiment for, or would we have to do an observational study? Well, observational study here, right? We can't force unhealthy seniors to vigorously exercise, or we can't force healthy seniors, right, that like to exercise to stop exercising, right? This is like not a treatment that we can just turn on and off for individuals. So we would have to do an observational study, right? This is where we identify a population, right? So let's go into the next step here. How would we design this? We'd randomly choose one group of seniors who already exercise vigorously, right? So you might have a questionnaire you would give them. They would describe, right, the amount of exercise they do each day. And from that group, we would pick those that say, yes, I exercise vigorously each day. And then we would choose a group from that questionnaire that do not exercise vigorously. Maybe they just, go for a walk once or twice a week. And then, since it's an observational study, all we can really do is monitor or observe the age of both groups at regular intervals. Now, if we're trying to decide, do they live longer, right? This is going to be a long-term study. It might take 5 or 10 years to really draw conclusions here, seeing how much longer the older folks live that exercise regularly versus how much longer do folks live that don't exercise regularly. So since this is an observational study, notice we can establish a correlation between exercise and longevity, but we would not be able to establish causality. All right, let's look at another example here. In this case, do flowers sprayed twice each day with a mist of water stay fresh longer than flowers that are not sprayed? So these would be cut flowers, right? Excuse me, like in an arrangement. So could we design an experiment, or would we have to do an observational study? Well, this is one we could use an experiment for, right? So how would we set that up? So we could randomly select the same number of flowers to be put into 2 groups, right? The control group and the treatment group. The control group would not receive spray, the treatment group would. So we would spray one group twice a day and do not spray the other group. And then we'd want to keep all the other variables constant, right? The temperature, sunlight, these are cut flowers, so they'd probably be indoors. right? So we want the cut flowers in the two groups to see all the other same conditions. The only thing that's different is that we missed one group of flowers twice a day. And then we would record, right, how many days the flower stays fresh in each group. And we'd have to come up with our criteria, right, for when is a flower no longer fresh. That could be a little bit subjective, right? But you'd have to have a standard that you would use to determine when a flower is no longer fresh. And let me back up. So in this group, we could establish causality, right? Because we have a control group, we have a treatment. This is a experimental statistical study. All right, last topic here. How do we analyze experimental designs? An important part of experimental design is the sample size or the number of subjects. Now, one way we can improve the validity or the confidence, right, of the outcome of our experiment is through replication. Which is to repeat the experiment under the same or similar conditions, right? So often you don't want to just do this once and say, oh, I got my result, but can you replicate it? Can you reproduce the same experiment or very similar to it and get the same results? And if you can do that multiple times, then you have very high confidence in the outcome of your experiment. So let's look at another example here. A company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Now, identify any problems with the experiment and how you would improve it. So here's how they set up their experiment. 5 overweight people are given the new gum. 5 are given a placebo, so placebo gum. Right? After 3 months, the 5 that used the new gum have lost weight. So what could we say about this? Well, our analysis would be that only 5 people, that is not a very large sample size, right, to be able to produce valid results. So how would we improve this? We would want to either increase the sample size or repeat the experiment with a different set of people and see if we get the same outcome, or even do both, right? Larger sample size and repeat the experiment a few times. Let's look at one more example. A company wants to test the effectiveness. Whoops, that's not what I want to do. Actually, it is, right? So we want to conduct the same test. Is the chewing gum effective in helping people lose weight? But let's look at a different way we could set up the experiment, right? So what if we did it this way? 10,000 people are identified who are overweight, and we divide into male and female groups. Females are given the new gum and males are given the placebo gum. After 3 months, a large percentage of females have lost weight. Now, would this be a good experimental design? Well, the good part about it is that they've identified 10,000 people, right? That's a very large sample size. So no problem with the sample size here. However, putting them into groups of male and female are not similar, right? That would not be a random grouping of who was the control group and who was the treatment group. So even if you did want to see the effect of men versus women, you would want to do a random sample within each group. In other words, a set of participants that are male receive the new gum, and a set of participants that are female receive the new gum. And that would allow you to have a truly randomized sample. We already have a large enough sample, but it's not randomized the way it's written. Okay, hopefully you're getting the idea here of what makes a good experiment design for statistical study. So we know how to describe experiments, right? A controlled experiment. We know about a control group and the treatment group. We know how to recognize that randomization is important as we design our experiments and observational studies. And we know how to analyze experimental designs, look at them and say, what could we do to improve them? All right, that's it.